Well, welcome to the Samara Training Occupational Health and Safety tutorial. This one is Module 5. My name is Jonathan Scopes. We're going to talk about 4 things this afternoon: noise, vibration, radiation, and mental health. So we'll start with noise. The thing with noise is it can affect us in 2 different ways. It can be a short noise, a really loud noise like a bang or an explosion that damages the ears, or it can be chronic, which means long-term and permanent damage. So if you listen to loud music, your ears may ring for a short time. That's an acute short-term effect. If you listen to noisy machines for years, that will be a chronic, long-term and permanent effect. There's no going back. There's no fixing your ears. You will have induced hearing loss and you will suffer social exclusion. You may know a grandparent who speaks really loudly because they can't hear. They think you can't hear either. Tinnitus is a damage to the ear that is that results in you hearing a continuous sound in your ear 24 hours, 7 days a week, and so it distracts and covers other sounds. We can measure noise in decibels, and in the UK we have limits of 87 decibels measured over an 8-hour exposure period, and shorter periods have louder exposure limit permits. So the noise you're allowed to listen to by the standard relates to the time that you're exposed to that noise. Why do we bother to measure noise? Well, first is it's a legal requirement. If you read Oman's Ministerial Decision 286/2008, you'll find that we should measure noise levels. We also measure it to control the noise. If we know how loud the noise is, we can make an effort to control it. We can use that measurement to protect people. We can say, this noise level is okay, but maybe this level is not okay. And we'll make decisions to protect people as a result. And then we can compare the noise level that we measure with the standard. And if our noise level is higher than the standard, then we need to do something. And if it's lower, we can reduce the noise as low as reasonably practicable, but we don't actually have to. So we measure noise in decibels. And now, interestingly, it measures in a log scale, a logarithmic scale. Normally we count 0, 1, 2, 3, 4. But with a log scale you count 0, 1, 10, 100, 1000. So when you move up in decibels, it's not moving up in a regular amount, it's moving up in an amount that is exponential, it is jumping up. So instead of going from 1, 2, 3, you go 1, 10, 100, 1000. So it's getting worse and worse. We can measure that noise averaged over a period of time, or we can measure that noise for a short period of time, measure the impact or peak noise. And we measure the noise over a sampling period. For daily use, normal use, most standards we measure over an 8-hour period, and for peak it's much quicker. These are UK exposure limits, and basically in the UK we have lower, upper and exposure limit values. Lower means think about doing something, upper action level means you must do something, and exposure limit value means stop the work and move people away or change it, but something must happen. And we can see there we've got in the middle column we've got 8-hour average and those values, and then the peak is C values, and those are much higher. But those really are high because, remember, it's a logarithmic scale, and actually the sound pressure in your ear is doubling for every 3 decibels of sound. So if it goes from 80 to 83, the sound pressure on your ear has doubled. Reducing noise exposure. Well, we can limit the time that we spend there. If there's a noise in that room, I could go in there for a short period and then come out and take a break. And that would be a good thing to do. That would protect my hearing. Or we could switch it off. Great, we switched it off. And we might switch off background equipment or ventilation equipment that we're not using. We can service or maintain or replace noisy equipment. Well, that's a good idea. It's a great idea. It takes the noise levels down, and you know from having a car that is well maintained has less noise. We can introduce engineering noise controls. These are things like silencers or acoustic insulation, sound insulation. We can put barriers in the way. So this concrete wall behind me is a good sound barrier. It's heavy duty and it resists the sound well. And then of course we can protect our ears, and I'll talk about that in detail. And there may be other things that you can think of to reduce noise. Keeping going, we can have isolation and insulation. So isolation means we separate the machine from its surroundings, and we can use springs and anti-vibration mountings. So those of you who know about car engines will know that the car engine is not actually clamped to the body of the car. It's mounted on rubber mountings, anti-vibration mountings, so the vibration and the noise of the engine is not transmitted to the body of the car. Or we can use barriers to stop noise transmission. And if you think of your car again, your car has a carpet on the floor, and that carpet is there to look nice, but it's also acting as a barrier to reduce the noise. We can use absorption. Absorption is taking a material that will soak up the sound and make it so it can't echo so much or come back off a wall to you. And if you think about going to a cinema, you will have seen the wall on the cinema has got material on it. The wall in the cinema is not smooth like this wall, but it's got this absorption material to soak up the sound. And then of course we can relocate noisy processes away from people. So you go to a desert camp in Oman, you'll find the generator for the camp will be away from or outside the camp, so that the noise of the generator isn't so bad for the people living in the camp. We can use damping to stop vibrating. So you can, if you have a piece of metal that is vibrating, you can stick some rubber on it so that it will not vibrate so quickly, and that will dampen the sound. You can use silencers. Your car has a silencer, and if your car didn't have a silencer, I would hear it coming maybe even 100 meters away. But that's why we have silencers. The best thing to do is attenuate at source. Attenuate means control it where it makes the noise. So attenuation is a good thing. So in a car engine's case, we put the silencer on it to help control the sound coming out, and we have the oil and other things in there to control the noise and help lubricate the engine. Or we can change the process to a quieter one. So if it's let's think of a factory. If it's a factory that fills bottles with liquid, let's say a soft drink, if it's glass bottles, they'll make a lot of noise. If we change the process and fill the drink, the liquid, into plastic bottles, that will be quieter, and that will be a good thing. Well, we can also use PPE. PPE stands for Personal Protective Equipment. Now in this case we're thinking about hearing protection. In general, PPE has limitations. The first thing is, if anything goes wrong with the hearing protection, my hearing is getting damaged. It fails to danger. The second thing is, it only protects the one person. So if I'm wearing hearing protection, you're not protected. The hearing protection only works if I'm wearing it. and it must fit. It's easily damaged. It may get in the way of other PPE. So as I stand here, I'm wearing glasses. Imagine they were goggles. If I was wearing safety goggles and put the ear muffs on, there'd be compromised because the sound would get through where the arm of my glasses are. If the PPE is working well, then I may not hear the alarms warning me about a fire or something. So that's a risk. Or I may not hear you when you come to talk to me. And the danger is you come to talk to me and I do this. And we have the conversation and I put the muffs back on. And while we are having the conversation, I'm exposed to the loud noise. Earmuffs, along with some items of PPE, are just not comfortable. So if you have worn earmuffs, perhaps off your hard hat, and they clamp onto your ear, after an hour or two you will understand it's not comfortable. Your ear will feel pressed and you may get warm round here. Even earmuffs require maintenance. They require storage, they cost money. So all these are limitations for PPE. So, sorts of PPE that we might use. We can use earplugs, which we put inside our ears. They are like bits of foam, and what you do is you roll them into a tight tube, and then you put them inside your ear. And they're good because they're disposable, so that means they're hygienic. My own experience of wearing them is they work loose, and I find it difficult to get them in. And the noise will still travel to my eardrums through my bone structure. And the same for you. Earmuffs, they get in the way of glasses and goggles, and they also need maintenance. But the advantage is, if someone's wearing earmuffs, even if you're a distance away, you can see, yep, yes, he's got his earmuffs on, that's good. Now we're going to talk about attenuation factors. Attenuation means how much noise does do the earmuffs reduce the sound level by. So let's say the manufacturers say, if you wear our earmuffs, the noise will be reduced by, let's say, 20 decibels. Now that's good. But the reality is, they tested their earmuffs in ideal conditions, in a factory, in a clean environment, with somebody who had no hair around their ears, with it was clean, it was a perfect environment, good condition, well-maintained earmuffs. The reality is, when we're on site, they don't fit so well, and so we should allow perhaps 4 decibel less attenuation than the manufacturers say, as a guideline. And then we need to check that the earmuffs work for the range of sound that we're experiencing. There's no good protecting me for high-level sounds if the problem is with a low-level sound, like on a diesel generator. The earmuffs must work for the type of sound that I'm hearing, high frequency or low frequency. So, why do we measure noise? Well, one reason is to find out what the person's level of hearing is like before we put them in a noisy environment. So let's say I'm a new employee, I arrive at your factory, and you test my hearing before I start working, and you established Jonathan's hearing is okay. Let's say it's at this level. Maybe after 3 months, you test my hearing again. And my hearing was there when you first tested it, but now my hearing level has dropped. I can't hear so well. Now you've detected that, you can take a positive action. You can do more to protect my hearing. And that's a good thing. When I leave your factory, maybe after a year or after 10 years, you can check my hearing again. And so if you know when I arrived my hearing was this level, and when I left it was this level, then you've got factual information to say Jonathan's hearing was okay when he left us. And that's useful for court cases. Maybe after 20 years I'm going to sue your company and say my hearing was damaged when I worked at your factory. And you come to court and you say, well, here are the hearing records. Jonathan's hearing was okay when he left us. The damage must have happened after he left us. And the other thing, another reason is, it shows management commitment. If the management take the time and the effort and the cost to measure people's hearing, they're showing that they're serious about health and safety and looking after their employees. There are different types of meters. We can have integrated meters. Integrated are sophisticated electronic meters that can average the sound over a period of time, like over 8 hours. And if the sound level varies up and down through the person's working day, then an integrated meter is a good idea because it will average the sound that they're exposed to. And I'll show a calculation about that shortly. And it will give you a value, a continuous equivalent noise level. This is the average value that the meter has read in an 8-hour period. Or we can use direct reading meters. So if this was a direct reading meter, it would be cheaper and it would be used for a steady noise. So if the person works next to a noisy machine, you can measure the noise now and it'll be the same noise level whether you measure it now at the beginning of the day or at the end of the day. And you get an instant reading. There it is. So it's cheaper to use and quicker to take the reading, but it will not register or record an average where the noise level has varied over the day. We can get sound level meters, which we set up, and they record what's going on. You can get personal exposure meters, dosimeters, that come round with me. So as I walk through my day, the noise has been recorded. You'd normally put it as close to a person's ear as you could, so perhaps you'd pin it on their shoulder, or on their clothing, I should say. And then you'd hear the noise that their ears were exposed to, because the distance between the two is very short. As with all meters, you must calibrate them. Calibration means I've tested the meter, let's say at the beginning of a period of work, and it's giving the right reading. And then I do my measurements, and I test it at the end of the period, and it's still giving the right reading. If the test at the beginning and at the end are okay, then I can believe the numbers I got in between. They're accurate. But suppose the calibration shows it was good at the beginning, it was accurate at the beginning, but at the end of the period, it was not accurate. It was, let's say it was measuring too low. Then I wouldn't know if I could believe any of these results in between, because I don't know when the calibration went wrong, whether it went wrong at the beginning or at the end of the measurement period. So calibration is important, and you need to do it regularly, because we want to be sure that the readings in between the calibration are accurate. So who's at risk? Well, construction workers. So they use jackhammers, they use drills, they have big equipment, and that all makes noise, and it's got the potential to damage their ears with a steady, loud noise. The military, if they have exposed to explosives or other explosives, then those bangs are going to damage their ears. One short bang may be enough to damage someone's ears. People who work in the music entertainment business, who play loud music, or who record loud music, or who are part of the technicians team, or the part of the hosting team of a big event, they're all exposed to the loud music, and therefore potentially to their ears being damaged. Manufacturing. So most manufacturing places have machines, and the machines make noise as they move pieces around, as the parts move around. And then people who work in call centres, phone centres, where they have a microphone for the headpiece on their head, and they're listening to calls all day with the sound in their ears, they're also potentially at risk. Right, we're going to move now from noise to vibration. In some ways, vibration is similar to noise, but instead of being the hearing we're thinking about, the vibration is affecting hand-arm or the whole body. So hand-arm vibration occurs when, for instance, I'm drilling a hole with a drill machine. and it's my hands and my finger and my arms and wrists and even my shoulders that are being affected. And you'll see in that second line it's got the acronym WRULD, that's upper limb, work-related upper limb disorders. What are the symptoms? Well, if I'm using a drill, it will probably start to feel numb, or I'll feel tingling in this finger, because it's usually the right hand that pulls the trigger on the drill or pulls the trigger on the jackhammer. So it'll start here. But if my whole hand is being vibrated, obviously not as slow as that, it's got to be very quickly, then what will happen is these blood vessels will get damaged. Because the blood vessels are damaged, the blood doesn't get through to the nerves and the muscles and to the bone, and we'll suffer damage to the hand. And I'll show a picture of that shortly. And that will lead to loss of grip. So instead of being able to pick up a heavy object with my hand, even a glass of water could be difficult if I've got a lot of damage to my hand, and I won't be able to feed myself or even perhaps to do up my buttons and get dressed. Whole body vibration. So if I'm on a big vehicle, on a bad road, my whole body is getting vibrated, and that will lead to back pain, maybe damage to the eyes and damage to the hands and controls, increased heart rate, and even blood pressure. So people who are exposed to hand-arm vibration will be people who use machines that vibrate, like construction workers using drill machines and jackhammers, and whole body vibration likely to come from trucks. You'll have seen on the modern trucks that they have, the cab seems to bounce on the top of a modern truck. That's providing whole body vibration protection to the driver. There's a spring in the cab that's been adjusted to his weight. So if it's a heavy man sitting, it has a different properties to if it's a light person sitting on the seat. So hand-arm vibration comes from power tools, and as I said on the previous slide, it damages the blood vessels, the nerves, the muscles, the bones and the joints. And altogether, the person is suffering pain, but also physical damage to the operation, in this case of his hand and wrists and his arm. And this is a picture of somebody with what's known as vibration white finger. If you look at his hand in the picture, you can see why it's called white finger. Because the blood has been reduced, the finger has gone white. So that's one of the signs. The symptoms are tingling and pain and numbness, and the eventual effect is his hand will become functionally useless, and he'll not be able to eat for himself, or even get dressed in the morning, and worst of all perhaps, not even go to the toilet, because he won't be able to undo his clothes to go to the toilet. So it's a very bad thing. The key with this is, if someone's experiencing numbness here, stop them working on vibration equipment now and protect them for the long term. Don't let them get to this stage. These are vibration exposure limits exposure values from the UK, and the thing to note is that there are different values for hand-arm and for whole body, and there are different values for daily exposure at action value and exposure limit value. So if I'm using a hand-arm vibration, let's say it's a drill machine, I can put a measuring device, clamp it to the drill, and I can measure how much vibration my hands are being exposed to. And you can set the meter to sound an alarm if it's too much. And the light will flash, and the person operating the drill will know I'm getting more than my 2.5 meters per second squared, and I can say to my manager, this drill machine is giving me too much vibration. Can we change the drill bit? Can we maintain the drill? Or can we replace it? Can we think of another way of doing the job? But at least we can do something about it. Risk factors for vibration. Well, one obvious risk factor is how long are you using the drill for, or the piece of equipment. So if I'm on a jackhammer, I want to be on there for a very short time, maybe 20 minutes. Another risk factor is the vibration very, very small, or is it actually moving my hand quite a bit? So a drill might move the hand a small amount, but a jackhammer will move it more, and that will be worse for the person using it. It will depend on the work schedules. Am I going to be doing this jackhammering every day for months? Or am I going to be doing it once only and then not at all for several weeks? So the work schedule matters. Then in the work schedule, during the day, you can put rest periods. So you might have a system that says, right, Jonathan does it for 30 minutes, then the next man does it for 30 minutes, then another man does it for 30 minutes, then after 2 hours, it's Jonathan's turn again. And then we give people breaks, rest periods. And the other risk factor, not so common in Oman, is cold temperature. You know, if your hands get cold, the blood drains from your hands, and your body is pulling back the blood from the arms and the hands, and from the ears and the nose, but we're thinking about the hands, and it's keeping the body core warm, the vital parts warm, the brain and the organs, which is good, but it means there's less blood going to the hands. If there's less blood because it's cold, then it's more likely the damage will happen, because we need the blood to feed and to oxygenate the nerves and the muscles. Engineering controls. Well, things we can do. In an ideal world, we can eliminate the vibration. So if it's jackhammering, can we think of another way to do that job? Could we do it by using a saw, a concrete saw, and cut the piece of concrete out? That would eliminate the problem. It would create another problem, another risk, but it would eliminate the vibration risk from the jackhammer. We can buy good quality equipment. Now you know from cars, for example, that a good quality car produces less noise and less vibration. And in this case, good quality equipment will vibrate less. We can plan maintenance. So we have a machine in use, and we can plan to have maintenance. In Oman, we routinely plan to have our car serviced after 5,000 or 10,000 kilometers. Why? Because it keeps it in good condition. And one benefit of that is less vibration. We can use PPE to personal protective equipment like gloves to keep our hands warm so the blood is flowing, so that we're protected that way. We can use administrative controls, so we can have breaks, we can have shifts, we can have job rotation, anything that reduces the exposure time to the vibration. And then we have what I've written there as IITS. We can inform the operatives, we can instruct them, we can train them, and then we can supervise and check that they are really doing the things they should be doing. Because you might find that they make the most junior person in a construction gang do all the work on the jackhammer. It's not only unfair, but it's also likely to damage his hands and arms. And another measure we can use is medical exposure, medical measurements. I can record how long is someone exposed. I can set limits as a company and say, no one is to use this piece of vibrating equipment more than, let's say, 2 hours per day. Set a limit, and then you have to enforce it. And that's where the supervision comes in from before. And then we can protect vulnerable people. So I'm an old man, so I would expect the company not to give me the job of using the jackhammer, because my whole body is in a less robust state than it was 40 years ago. Protect pregnant women, again, to look after them and the unborn child.